Hi guys, this is lesson 1 in unit 2, which is solving equations and ratios. First thing we're going to start with is solving one-step equations. We have an example. We have 3x equals 21. You guys learned how to solve one-step equations in middle school. So solving this problem is going to be a review for whatever you learned in middle school. So the first step is to put this line over the equal sign to remind ourselves that between these two sides, we need to use the inverse operations to be able to move expressions from one side to the other. We don't have to use the inverse operations when we simplify expressions on the same side. We only use inverse operations when we move expressions from one side to the other. And we know that the inverse operation for addition is subtraction. For multiplication, it's division. We know the inverse operation for subtraction is the opposite, addition, and the inverse operation for division is multiplication. Okay, so let's start. We have 3x equals 21. We have 3 multiplied by the x. To get rid of that 3 or move it to the other side, all I need to do is to divide by 3, because division is the inverse operation of multiplication. That means I need to divide by 3 on both sides. And I'm going to end up with x equals 3 and 3 are going to cancel each other. And I'm going to end up with 7. Now, how can I make sure that my answer is correct? The only thing I need to do to be able to find out if my answer is correct or not is to do what we call the check, which is basically substituting the value of x, which is in this case 7, in the equation and evaluate the equation to see if we're going to have equal sides at the end. So in this case, I'm going to switch x with 7. And I'm going to evaluate both sides. The right side is already done for me. It's 21. I need to make sure that the left side is equal to 21. We have 3 times 7, which is 21. That means that the left side is equal to the right side, and my answer is correct. Now let's solve two-step equations. And in this case, we're going to have to use two steps to be able to have x by itself in the equation. That's why it's called two-step equations. So in this example, we have 3x minus 12 equals 8. To be able to have x by itself, I have to get rid of negative 12 first. We know that the inverse operation for the subtraction is addition. But first, I'm going to put my line over the equal sign, because again, I need to remind myself that I need to use the inverse operation every time I need to get rid of a number or move number from one side to the next. So in this case, I'm adding 12. So the negative 12 and 12 are going to cancel each other, and I'm going to end up with 3x by itself on this side. And on the right side, I'm going to have 8 plus 12, that's 20. So now I need to finish this problem by getting rid of 3. and 3 is multiplied by the x. That means to be able to get rid of 3, I need to divide by 3. And again, since I'm getting rid of a number, I need to do the same thing on the other side. So I'm going to end up with x equals 20 over 30, which is in the simplest form. That's why I'm going to just leave it as it is or change it into a decimal, both correct. We're not going to have a problem with that. So to make sure that our answer is correct or not, all I need to do is to do the check. And again, the check is basically substituting the x value in the equation. So I'm going to have 3 times 20 over 3 minus 12. And I want to make sure that this side of the equation is going to be equal to 8. So if you put the left side in your calculator, you'll end up with 8 equals to 8, which means that we solved this problem correctly, and the final answer that we have in here is the right answer. Now we're going to learn how to solve equations with parentheses. The key factor is every time you see parentheses in an equation, you have to simplify that equation by getting rid of the parentheses. And we get rid of parentheses by using the distributive property. So in our first example, we have 3 times x minus 4 equals 21. I'm going to use the distributive property to substitute 3 into x minus 4. That means I'm going to have to multiply 3 times x, which is 3x, and 3 times negative 4 equals negative 12. As you notice here, I have my line that I put over the equal sign to remind myself of what I need to do between the two sides. So I end up, after getting rid of the parentheses, I end up with two-step equation as the previous example. Now all I need to do is to get rid of negative 12 by adding 12 to both sides. So when I add 12 to both sides, I'm going to end up with 3x on one side and 33 on the other. Again, I have 3x on one side. I need to have x by itself, which means I need to get rid of 3 by using the inverse operation. In this situation, I'm going to have to divide by 3 on both sides, and the final answer is going to be 11. Now, we can do the check to make sure that our answer is correct by substituting x, 11, for x in the equation and solving the left side of the equation, which makes us have 21 at the end, which is equal to the right side of the equation, which is 21. That means we did the work correctly, and our final answer for x is 11. Now let's solve equations with the same variable on the same side. So our example is 3 times x minus 4 plus 6x equals 21. I'm gonna start by getting rid of the parentheses, because again, every time we see parentheses, we need to get rid of these parentheses. So I'm gonna end up with 3x minus 12 plus 6x equals 21. As you notice, we have 3x and 6x with the same variable, which means these two are like terms. Since these two are on the same side and they're not on opposite sides, we don't have to use the inverse operation. We learned in Unit 1 that all we need to do to simplify this expression on the left side is to combine like terms. And this is what we need to do. Combine 3x and 6x together will give us 9x. And I'm going to end up with 9x minus 12 equals 21. Now, I end up with two-step equation, which means all I need to do now is to get rid of negative 12 by adding 12, And then this means that I'm going to end up with 9x equals 21 plus 12 is 33. We divide by 9 to have x by itself. And again, when you get rid of a number, you have to do the same thing on the other side, which means the final answer is going to be 33 over 9, which is 11 over 3. So now to check your answer and make sure that this is the right answer, all you need to do is to do the check. Now let's learn how to solve equations with the same variable on both sides. So our example is 3 times x minus 4 equals 4x plus 8. And the first step, again, is to get rid of these parentheses. So I'm going to use the distributive property. And then I'm going to have 3x minus 12 equals 4x plus 8. Again, I'm going to put my line over the equal side. And as you notice, 3x and 4x are on opposite sides of the line that I have here, which means to get rid of one of them, I'm going to have to use the inverse operation. Since I have 4x and 3x, and 3x has the smaller coefficient, I'm going to get rid of 3x on this side, which means I'm going to have to subtract 3x from both sides. So what I'm going to end up with is negative 12 by itself on the left side, and then 4x minus 3x equal 1x plus 8. Now this is a one-step equation. All I need to do is to have x by itself, and to have x by itself, I need to subtract 8 from both sides. Now the 8 and negative 8 going to cancel each other, which means I'm going to end up with negative 12 minus 8 equals negative 20. Again, I can do the check to make sure my answer is correct by substituting every single x that I see with negative 20 and using the calculator to find the value of the right side and the left side. I'm going to find out that both sides are equal to each other, and this means that x equals negative 20 is the right answer for this problem. Now let's take a look at a problem where we have a ratio to deal with. So we have x plus 6 divided by 3 equals 8. This problem would be much easier if we don't have a ratio or a fraction, and if we don't have a denominator. And the left side of the equations mean x plus 6 divided by 3. So to get rid of 3 at the bottom of the ratio, I need to multiply the this side by 3 and the other side by 3 by doing the inverse operation of division. That means I'm going to have to multiply this side by 3 and the right side by 3. And I'm going to make my line over the equal sign to remember to do the inverse operation. Now this means the denominator is going to cancel with the 3. I'm going to end up with x plus 6 by itself, which is much easier to deal with when we don't have a fraction and we don't have a denominator. Equals, and then we have 8 times 3, which is 24. Now this is a one-step equation where we have to get rid of 6 to be able to have x by itself. The inverse operation of addition is subtraction. That means I need to subtract 6 from both sides. That allows me to have x by itself on the left side. and then I'm going to end up with 24 minus 6 equals 18 on the right side. Now I'm not going to do the check, I'm going to let you do the check yourself. And in this problem, if you do the check, you're going to end up with 2 equal sides, which means the final answer is correct, and it's going to be 18. Now let's take a look at a second problem. We have 3 equals 2 over 5y plus 1. So we have a ratio or a fraction, and we have a two-step equation here to deal with. So the first thing that we need to do to be able to solve this problem is to get rid of 1, because getting rid of 1 is going to make the problem easier. And to get rid of 1, I need to do the opposite, which is subtract 1 from the right side and subtract 1 from the left side. I'm going to end up with 3 minus 2, 1 equals 2, which is equal what I have left here, which is 2 over 5y. Now, to have y by itself, I need to get rid of the fraction, which is 2 over 5. And since we have a fraction, we need to use the reciprocal to get rid of that fraction. So by multiplying by the reciprocal on this side, which is 5 over 2, and multiplying 5 over 2 on this side, the denominator, which is 2 and 2, they're going to cancel each other. 5 and 5 are going to cancel each other. I'm going to end up with y by itself, which is going to be equal to the 2 here and the 2 here are going to cancel each other, and I'm going to have 5 by itself. So the final answer is y equals 5. And if you do the check, you'll find out that both sides of the equation are going to be equal to each other if we substitute y with 5. So here we have one more problem where we have a ratio equal to a ratio. That means we have a fraction equal to a fraction. And the best way to solve this equation is to cross multiply. And cross multiplying is basically multiplying. This is the equal signs that we have. That's why we're allowed to do cross multiplying. We're going to have to multiply the 2 by x minus 2 and multiply x by 3. So I'm going to end up with one side having 2 times x minus 2 equals to the other multiplication that we have here, which is x times 3, which is 3x. You have to keep x minus 2 in parentheses because that's the denominator of one of the ratios in this case. So now that we have parentheses, we need to use the distributive property, which means I'm going to multiply 2 by x and 2 by negative 2. 2 times x is 2x. And 2 times negative 2 is negative 4. It's going to be equal to 3x on the other side. Now we have variables on both sides. That means to be able to move one of these variables to the other side, I have to use the inverse operation. Since 2x here have a smaller coefficient, I'm going to have to take it away to the other side by subtracting 2x from both sides. So I'm going to end up with one number on the left side, which is going to be negative 4. And then on the right side, I'm going to end up with 3x minus 2x, which means it's going to be just x. And I'm done. X by itself is x is by itself. That means I'm done with this problem, and the final value for x is negative 4. Now to do the check again, all you need to do is to substitute each x in the first ratio with negative 4. So I'm going to have 2 over negative 4 equals 3 over negative 4 minus 2. So 2 divided by negative 4 is going to be negative 2. And the denominator here, negative 4 minus 2 in this case. I'm sorry, this is supposed to be 1 over negative 2 equals. The bottom here is negative 6, which means I'm going to end up with 1 over negative 2, because 3 over negative 6 is 1 over negative 2. That means I did the work correctly, and the final answer for x is negative 4.